Hey folks, we're looking for non-integer rational numbers. Non-integer. I guess we need a hyphen there. Non-integer rational numbers, the ratio of two integers. Well, let's call it fraction. All right. Now, y'all, just to make sure you understand what this means the rational numbers minus all the integers. It's set theoretic. You can write this as q minus z. I've seen it done that way, set theoretically q minus, where it means minus in the set theoretic sense. Now, just to get an idea of why I'm being so picky about the notation, notice that a number like 7/1, it's an integer, but you can write any integer as a fraction, right? So we're looking for non-integer fractions here. Now, let's move along. Most of the work is done. The key thing to notice here is that 172, I think, what is it, equal to 4 times 43. But 4 is, of course, 2 squared. So that's why when we square root this object, we get 2 root 43. Okay. Now, here's where the neat thing is. I just say 1 like it's a big deal, like it's special to find one. But you can find infinitely many rational solutions. I just arbitrarily, you see the 2 we get right here, the 2? Well, you can write that as 3 plus 11/7. 14/7 is 2, right? So look at that. And there's an infinite number of ways to express 2 as the sum of two non-integer rational numbers. Okay. And so all we did is just split it apart here. 3/7 root 43, 11/7 root 43. Pretty cool how this works out. It's very simple, in fact. It's easier really than finding all the integers. Less work in many regards. And so here we go. We get the solutions. Okay, folks, see what we did here. Remember, this said the square root of m, so we had to square it to get m. All right, and then these are the two values. I think I did these computations correctly. But anyway, these are the two rational coordinates that satisfy, and just one of the infinitely many. There's only finite natural number solutions, but there's infinite rational solutions. And also, nothing would change if you tried complex numbers. I haven't done one yet, but it's kind of hard to imagine complex numbers coming into play here. But remember, you can take the square root of a complex number, and you can get two complex numbers to add up to 2 an infinite number of ways. So there would be an infinite number of complex solutions as well. Okay? All right, that does it. Let's see. I won't rewrite that. It's just right down here. M is 387/49, and N is 52/03/49. Again, not to beat a dead horse, there's an infinite number of ways you could express 2 or any integer as the sum of two rational numbers. So this is just one of the solutions, just an arbitrary choice right here. All right, that's all. Thanks for viewing.